Hello and welcome to today's lesson on highest common factor, which is often written as HCF. But to start with, a little activity I'd like you to do. I'd like you to remember back to prime factor trees, and I'd like you to write 45 as a product of prime factors, and I would also like you to do that for 128 and 360, and to do this I would suggest you use your prime factor trees. Off you go. Now, if you happen to have forgotten prime factor trees, what I'd like you to do is write your 45 at the top, so this is a quick reminder, and 45 you want to write that as the product. Remember, product means multiply, so as the product of two numbers. So I'm going to choose 5 and 9. I then have to go, is 5 prime? Well, 5 is a prime number, so I'm going to put a circle around that because that's it, that's a prime number. And 9 is not prime. How can I make 9? I could make 9 by 3 multiplied by 3. So is 3 prime? Yes, 3 is prime. So let me circle both of those, and then I can write that 45 is equivalent to 3 multiplied by 3 multiplied by 5. So if you remember back, these here are our prime factors, and when you multiply them together, 3 times 3 is 9, times 5 is 45. You may have done that one and got it correct already, and you can just carry on to B and C and see what the answers are. If, however, you'd forgotten how to do it, press pause now and have a go at 128. Remember, if you need to, rewatch this little bit of video before you move on. Off you go. So now, just coming up with the answers for 128 and 360. To do this, I'm going to go here. So 128. I can look for any number that would go into there, and I'm going to choose 4. You could have chosen many different numbers, so that would be 32. Is 4 prime? No, I can carry on. 2 and 2, and 32, I'm going to do 4 and 8, and that would carry on 2 and 2 and 4 and 2 and 2 and 2. So 128 can be written, and if I look at all the prime numbers, remembering 2 is a prime, it's our only even prime. So, and it's multiplying 2 by itself 7 times. 2 multiplied by 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 2. Any ideas? Can you think of how I could perhaps write that a simpler way? Well done. I hope you've got there. It's 2 to the power 7. But both ways are really worth writing down, particularly for where we're going to use this skill later in our lesson. And last of all, 360. I would just do this one quickly and give you the answer. So you should have written out your tree diagram. Again, just a note that you may not have chosen 36 and 10. It doesn't matter which initial factors you choose, it will always work and you'll always get the same answer as me. If you haven't got the same answer, it's likely you've made a mistake. So go back, have another look at your work. So let's write this. 360 is equal to 2 multiplied by 2 multiplied by 2 multiplied by 3 multiplied by 3 multiplied by 5. And again, just showing you how that can be written in index form. It would be 2 cubed multiplied by 3 squared multiplied by 5. So there we go. Check both those off. If you got all three of those correct, well done. If you haven't, just review that video before we move on any further. So the focus of today's lesson is the highest common factor. What is the highest common factor? I just want you to pause and think about that before we go on. Do you know what the word factor means? Because that's important. And then we're going to go on to the highest common factor. What I'd like you to write in your books now is, what is the definition of a factor? You should already know this. If not, this is where you're going to go and have to look that up before you carry on with the lesson. So, going to need to press pause, go off, find what a factor is for me, and then come back. So hopefully you've come up with a definition for factor and you've reminded yourself what those are. One of the ways I like to remember what a factor is I like to say it is a number that divides into another number giving an integer answer. And if you're wanting to just understand what that means, if I just go back, here I can see that 2 is a factor of 360, and if I do 360 divided by 2, my answer is 180, which is an integer answer. So it also works if I choose the number 3, because 360 divided by my factor, which is 3, gives 120, which is an integer answer. So again, a factor, it's a number that divides into another number, giving an integer answer. Okay, so now we're moving on and we want to know what a highest common factor is. So I want you just to have a moment, have a think. What could a highest common factor be? Well, a highest common factor links to what a factor is, and we need two different numbers here. So we may have the number 10 and the number 12, and we want the highest common factor of both of them. And for here, and we're going to write a definition for this, so we have that in our books to look back at. The highest common factor and this is often written in shorthand as HCF, so that's something you're also expected to know, is the highest integer. Notice that important thing of that integer again, that can divide exactly, so that means with an integer answer, into 2 or more integers, because though the example I gave you was about 10 and 12, it could be more, with no remainders, which again focuses on that idea of it dividing in exactly and giving an integer answer. So press pause, make sure you've written that down in your book, because it is a definition you'll need to go back to, just like I asked you a moment ago about knowing what the definition of a factor was. And it's important that we remember them. When you've copied that down in your book clearly, then press play and we'll carry on and we'll start using and finding the highest common factor. Great, well done for writing that down, and let's look at this. So we want to write down all the factors of 12 and 18. Now I just want to clarify what this is asking for. It is not asking for the product of prime factors, which is what we did at the beginning of the lesson. This is asking for all of the factors of 12 and 18. And this is something that was covered before. So we're going to have a bit of a reminder on this. If I take the number 12, and how can I make 12? It's always best to start with the number 1. So 1 multiplied by 12. Can I do 2? Yes, 2 multiplied by 6. 3 multiplied by 4. And 4, that's a repeat. Do you notice we've already got 4? So actually I don't need to do that one and I can stop. So what are my factors? They're going to be 1, 2, 3, 4, 6 and 12. Now another way of doing this, which I've often seen, is people put 12 in a box like that, and they might do it like this and write them. So you may have been taught that method equally previously. All methods are good, just as long as you've managed to get out those. Now have a go. Can you get out all of the factors for 18? Press pause and have a go. Okay, I'm going to do it using the method I used earlier. 1 times 12, 18, because it's not 12. 2 times 9. 3 times 6. 4. Oh, does 4 go into 18? No, that doesn't work. 5. Does 5 go into 18? No, that doesn't work. 6. Oh, hold on a moment there. Got 6 already, so that's it. I've got to the beginning. Back to the beginning there. So here I'm now going to go for writing my list out. 1, 2, 3, 6, 9, 18, and there's all of my factors of 18. Now the question I'm going to ask now, having got those, is, and this is a question that links to what we're learning today. So what is the highest common factor of 12 and 18? So common, it's going to actually be in both lists of factors. So they both have a common factor of 1. But is 1 the largest common factor? No, 2. 2 is larger than 1. But I've also got 3. And have I got 4 in both of them? No. I've got 6 though. Are there any others that are common? No. So of my list of factors, I have 4 common factors, but my highest common factor is 6, because that's the one with the highest value. And remember, 6 should divide 12 and 18 exactly, giving an integer answer. And it does. 12 divided by 6 is 2. 18 divided by 6 is 3. So that definitely does work. 6 is definitely a factor of 12 and 18. And by looking at our list, we can see it is the highest. what happens when the numbers are larger? Let's look at these. We've got here the numbers 36 and 90. And if I was going to list all of my factors for 36 and 90, it would take me quite some time. And I also would be a little worried that I'd missed one out. And if those numbers get much bigger, that would be taking a considerable amount of time. So what we can do is actually use our knowledge of prime factor trees for these. And so I'd like you to write out the title, but also underneath put 36 and 90, and I would like you to do your factor trees, and I'd like you to write 36 and 90 as the product of prime factors, which is what we did as a bit of a refresh at the beginning of the lesson. So press pause, have a go. When you've done those, press play. So what you should have got is 36 is 2 multiplied by 2 multiplied by 3 multiplied by 3, and you should have got 90 equals 2 multiplied by 3 multiplied by 3 multiplied by 5. And when you're doing those, what we're going to do now is look at how can we use this information to help us find our highest common factor. Well, we're going to use something called a Venn diagram. And for a Venn diagram, we're going to draw a rectangle. And we are going to put 2 circles in that Venn diagram. And this circle on the left here is going to be our circle for 36, and this circle on our right is going to be for 90. Now let's have a look. I want us to look at the things that are the same in both and that are different. So I'm going to get a different colour pen for this. I have a 2 there and I have a 2 there. Do I have another 2? No, I have a 3 there though, and I have a 3 there, and I have another 3 here and another 3 there. Are there anything else the same? No. Now, that means in both of these we have a product in our factors. We have a 2, a 3 and a 3, and a 2, a 3 and a 3. So that's something that's the same about them, and they go in the overlapping part, which is here. Now if we go back to 36, the only bit that's not in the overlapping part is the 2. And if we go to 90, the only part that's not in the overlapping part is 5. And just to help you see this maybe a little clearer, if I draw this circle, I go back round this one in green, everything that's in the green circle is the 2, 3, 3, 5, which is what we have there. And if I look here in this black circle, what have I got in the black circle? I've got a 2, a 3, a 3 in the middle here, and I've got the 2 because this circle goes all the way round here. So I've got 2, 3, 3 and the 2, which is what I've got here. So the overlapping part means that it's in the 36 as well as being in the 90. Now this bit that overlaps means these factors, these are in both 36 and 90. And remember, these were products. So to find our highest common factor, we can write 2 multiplied by 3 multiplied by 3. And if you can work that out, so 2 multiplied by 3, that's 6. Multiplied by 3 again, that's 18. 18 is our highest common factor. So just going back through that, we drew out our factor trees, we wrote our numbers as products of prime factors. We then represented those in our Venn diagram. And this is something I do want you to practice because it's going to help us later when we move on to the lowest common multiple. So it is something I do want you to practice. And this in the middle here where it overlaps, these were in both of them. And that was our highest common factor. And remember, we multiply them because this is the product of prime factors. And we had the answer of 18. And with a bit of practice, that will be a lot quicker than you listing out for very large numbers. Make sure you've copied that all down. Make sure you just go back over that video and understand it before we go on to the next one. So press pause, and when you're ready to move on, press play. Okay, the next example. So, where do you think we're going to start for this? It says using prime factor trees and Venn diagrams. Remember, a Venn diagram is our rectangle, which includes all of the data and the circles in between it, inside it, and then you need to find the highest common factor of 96 and 120. So where are you going to start? Have a think. What would you do to start with? Now I'm hoping that you've decided to find for me the product of prime factors by doing factor trees. Well done. Press pause. I want you to do this example in your books, and when you've finished, press play. Off you go. So I'm hoping that you have managed to complete those factor trees. If not, you need to pause and have a clear look at these and understand them, of how I've ended up with the results that I have. And we can see that we've written 96 as the product of primes, and we've also written, can see I've missed one result out there. I've missed out one of the 2's. So let me just put that in so that I don't get the wrong answer later. And here I've written 120 equally as the product of primes. So now we're going on and we're going to draw our Venn diagram. And remember, we start with a rectangle and 2 circles. So you need to draw this out. This is 96. This is 120. And what I'd like you to do is try and fill that in. So press pause. When you've had a go and you've done that, press play. So I'm hoping that what you've done is you've looked for the things that are the same. So I'm going through and I'm circling those to make sure that I have included all of the values which are the same. So if you notice, I've circled 2, 3 times in both of them, and one of the 3's. And they are the values that go in the middle, if we remember. So 96, and I'm just going to draw them different colours because I think that helps us to see. So this is my circle for 96, and this here is my circle in green for 120. So for 96, the numbers which were not included are here, the 2 and another 2. And for 120, it's just the 5. Because if you remember, in the black circle here, which is 96, we now have all of the values For 96 and for 120, it's that green circle and they're all in there. These values are in both, so they go in the overlapping part in the middle. It's where the two circles intersect. So there's a word you may not have heard before. It's where they actually intersect the two circles. We put the values there in the middle. So what's our highest common factor? So our highest common factor, notice I'm writing HCF there, is going to be 2 multiplied by 2 multiplied by 2 multiplied by 3, which are our values in the centre there, and we multiply those together because it's a product and we get 24. So 24 is our highest common factor. Remember, it's the highest common factor. We're not looking for any factor, we're looking for the highest factor that is common for both of them. Now, if there's anything you didn't quite understand there, let's go back, review it before you move on and tackle the questions. So, hoping you've got that all sorted now, I'd like you to have a go at these. You need to draw out prime factor trees for each of them, and then you need to complete them and find the highest common factor. Off you go. Okay, you should have managed to work out the answers now for questions 1, 2 and 3. And here they are. So the highest common factor for question 1, that is 12. The highest common factor 48 and 90 is 6. And the highest common factor for 30 and 105 is 15. Check back. Hopefully you've got the correct answers. If not, something's gone wrong, so I'd like you to redo those questions before you move on, and importantly do a little bit more practice on this to ensure that you fully are secure. And then the next thing to learn is lowest common multiples.